All right, students, so this is Mr. Morris coming back to you. It's time for class for Thursday. I believe that is March the 26th. Check me if I'm wrong on that. But either way, this is Thursday's lesson for my algebra classes. I'm doing one video this particular time because you kind of both, it's weird. With algebra 1 and 2, of course, they're both algebra and they overlap in so many areas. But this skill that I'm going to go over is absolutely foundational to both Algebra 1 and 2, and we're both at that section more or less in each one of the classes. So I'm going to just give you both a quick snapshot into how we are going to attack algebraically, I say that again, algebraically solving quadratic functions. So in the past, we've looked at, I might come over here for a second. So, lately, in at least my Algebra 2 classes, we've looked at what a quadratic function looks like, and it always makes a U shape, or we call this a parabola. And the part where it crosses the x-axis, right here and right here, in this particular example, are called the x-intercepts. You've heard me say that in class. Another word for those are solutions. You could also say the zeros. There's all different words that all mean the same thing. And so in this case, where it crosses the x-axis here is at x equals 2 and x equals -2. So these are the two solutions. Quadratics always have two solutions. So where it crosses the x-axis, those are your solutions. You can always find the solutions, or most of the time you can find the solutions, I should say, simply by graphing it. If you had a calculator that could graph it, or if you did a table, and wherever it crosses, those are the solutions. But we're going to talk about how to algebraically figure out these solutions instead of having to look at a graph, because sometimes, even interpreting graphs and where it's exactly hitting can be difficult. So we're going to go back, just like I've said in class before, algebra, well, really mathematics, it builds on itself. So we don't just throw away, the baby with the bathwater just because we finished one unit. Guess what? We still get the factor. I know you're so excited about that. Matthew, oh, you love it. Ellie, you know it. I'll talk to Taylor Swift. Maybe she'll write a song about it. But no, for real, we're going to do a process called solving quadratic functions by factoring. So we factored that we just took a test on it, and now we're going to use those skills we learned on that test to figure out how to find the x-intercepts of the graph. Isn't that awesome? So, yes, it is, Mr. Morris. I know, it is. So let's do it. So you're looking at this quadratic function. This is example 1, x squared minus 11x plus 24. The key here is when it says equals 0, or you see an equal sign. That lets you know you need to solve, not just factor. So we're going to do the same thing we've always said. We said, how many terms does it have? 1, 2, 3 terms. So I guess that means, let's see, there's no GCF. I guess that's what multiplies to the outside and adds to the inside, right? Same rule applies. What multiplies, can you read that? Multiplies to the outside, but the same two numbers have to add to that inside number. So just like we tested on, you got to do two binomials with parentheses. Think, what multiplies to 24? But those same numbers, if I were to add those numbers, would equal -11. You might have to think about it for a minute. So let's go through the factors of 24. Well, we got 2 times 12. That equals 24. But no way does 2 and 12, no matter what sign I give them, ever going to give me 11. So I'm going to cross that out. Another combination could be 6 times 4. Okay? 6 times 4 equals 24. But when I add 6 plus 4, it gives me 10. If I subtract them, it gives me 2. Ain't going to work. So I keep thinking, 24 and 1, nope. How about 3 and 8? Ding, 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 ding. That's your winner, I think. Let's see. 3 and 8. Yes. So the key is getting those signs right. So we want to do a -3 and also a -8. The reason is a negative times a negative will equal a positive, so positive 24, and a negative plus another negative equals a bigger negative number, or a smaller number. It depends how you look at it, right? So that's going to equal -11, so that's my winner. Now, if we were just doing a factoring test, we'd be done right here, but the task here is to solve by factoring, and it's actually quite simple. You simply take your two factors, set them equal to 0, and solve for x. So we're going to do this one together right here. Take a look. We're going to do x minus 3, and guess what? We're going to set it equal to 0, okay? And then we're going to solve. So x minus 3 equals 0. How do I solve that for x? Well, I look at the sign, minus 3, and I do the inverse, right? I do the opposite. I add 3 to both sides. That cancels out. I'm left with x equals 3. Boom. There's one of my solutions. Now, do the same thing with x minus 8, that factor. I'm going to do x minus 8, just copy it down, set it equal to 0, and I'm going to solve. Add 8 both sides, cancels out, x equals positive 8. So, if you were, by the way, you are done. These are the solutions. It is that simple. If you were to actually graph this, I'm not sure exactly how big the parabola is, but I can tell you that it's going to cross about 1, 2, 3, 4, 5, 6, 7, 8. It's going to cross on the 8, and it's going to cross on the 3. So if we just imagine this parabola, I don't know how low it goes because I'm not worried about that for right now. I just want to know where that parabola would theoretically hit on the x-axis, and that would be at this point here, x is 3, and at this point here, x is 8. That is what we just figured out mathematically, algebraically. Okay? So there's your first little taste of how to solve by factoring. Let's take a look at another one, because this could take some practice. All right, so we have another similar setup. I didn't use the variable x, I chose to use n, same difference. Oh, there's that equals 0, so I know I gotta solve it, not just factor it. So I'm gonna do the same thing. Do my two binomials, all right, bring that down. It's n squared, so I know n and n. What multiplies to 10 and adds to 7? That shouldn't take you too long. 2 and 5 are the first factors I think of, and lo and behold, they do add to positive 7. Nice and pretty. They're all positives. Keep it simple, okay? So we just took a test on this. Most of y'all seem to grasp this concept for the most part. We're just taking it one step further. We're taking each factor, set it equal to 0. Each factor, set it equal to 0. We're going to solve each of them, all right? So n's going to equal negative 2, but it's also going to equal negative 5. So where that parabola would cross the x-axis is at the negative 2 and at the negative 5. Okay? Now, before you get too excited, I want to show you guys something that the algebra people love to do to you. So let's say you saw a quadratic equation like this. Oh no, Mr. Morris. That doesn't say equals 0. That says equals negative 7. Oh, I want to quit. Don't quit. Don't do it. All right? Taylor Swift doesn't quit. You know? Roblox don't quit. Matthew knows what that means. Okay? We got to stay with this. So we need to set it up to look a little more similar to what we've been accustomed to seeing. And that's not too difficult because this is an equation. As long as it balances, you can rearrange it. So what I like to say is, see this equals negative 7? I'm just going to add it back over to the left side. Guess what? Negative plus turns into a 0. Ooh, that looks familiar. And then I just rewrite what I have. Boomity boom. Okay, now this situation looks a lot more like what we've just gotten used to seeing. We don't feel so intimidated, right? Right. Okay, so here's the thing. Don't just assume because you see a coefficient here that you got to do the ACB method like you might be thinking right now. Because I always say, pluck that one string guitar. Ding, 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 ding. GCF, 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 GCF. If there's a GCF, you need to deal with it. I'm a horrible singer, and I dropped out of piano really young. So don't quote me on my music skills. But the truth is, GCF needs to be factored out. There's a GCF of 7, people. So I'm going to put 7 as the GCF. It goes into all 3 terms, and I'm rewriting what's left. That should be negative 2 plus 1. Boom. Now we got an interesting situation. Because now that I factored out the GCF, I have a quadratic trinomial. If I look inside the parentheses there, that fits what we want to do. Because R, right? What multiplies to 1 and adds to negative 2? Well, that would be minus 1 and minus 1 would do that. Okay, negative times a negative is a positive. 1 times 1 is still 1, right? And a negative 1 plus a negative 1 equals a negative 2. So that still works. I'm running out of room here, so I'm going to come up here. These two factors, you can kind of ignore the GCF of 7 at this point, to be honest with you. All right, but right here, these two factors, R minus 1, got to set it equal to 0 and solve. Okay, so R equals 1, and it's just the same thing. So I know it's just going to be r equals 1 2 times. Okay? In case you're worried what that, sorry, let me say that again. In case you're interested, what that would look like on the graph, you're like, hey, how can there be 2 1s? Anytime there are 2 of the same number, what it means is that the parabola touched, it came down and just kind of bounced right off of it, okay? So anytime you see a graph and the parabola just kind of boings in one spot, goes right back up, doesn't really even cross over, that means that there are 2 solutions at that point. Ain't that interesting? Okay, you might want to remember that because that's a good fact. All right, are y'all with me? How fun. I mean, I'm throwing it at you today. Okay, so we have just solved 3 quadratic equations by factoring. We were making the connection between the solutions that we got and where they would be graphically. Okay, see, 3 and 8, see that? All right, just recapping what we've done. You with me? All right. Tyler, man, this is so cool. You could even, we could do donuts every single week like this. Just get some coffee, get some donuts, watch a video, have math. I mean, come on. Don't tell me math's not fun. Okay, so we're moving on. And Nick and Ashton, I haven't forgotten about you either. Okay? Okay, so take a look here. We got the quadratic formula. What is that, Mr. Morris? A formula? Quadratic formula? Yeah, it is. And I'm going to give it to you right now because, annoyingly enough, there are some quadratic functions that actually cannot be factored. Now, I'm not going to be so mean to give you one that can't be factored right now, but it's coming, so just get ready, okay? Sometimes, no matter how hard you try, there is no number that multiplies to the outside and adds to the inside, and you're stuck. Yet, there still can be solutions. So there's this trusty dandy quadratic formula that somebody smarter than me came up with back in the day. And it goes like this. It goes negative b, you need to write this down in your notes, by the way, plus or minus, this is weird, the square root of b squared minus 4ac, and I like to say all over 2a. Okay? Now, if you want to just see something very entertaining, this is mainly for Matthew and the guys. Ellie, you might want to be interested too. There's a pretty, it's kind of almost, it's almost sadistic in some ways, but there's a funny YouTube video called the Quadratic Formula Song. Feel free to look it up if you want to. And it's this funny guy, and he sings this dramatic song about the quadratic formula. And it goes something like, quadratic formula, and it's negative b plus or minus square root of b squared minus 4ac over 2a. All right, that's all I'm going to say. It's pretty good. And it seems like, Nicholas, I'm talking to you too. I think you'd appreciate this song. Look up the Quadratic Formula Song. It's a cartoon. It's kind of funny. And now, knowing you and Matthew's sense of humor, I feel like this is going to hit you right in all the right levels, okay? I might post the link to this song if Olivia will let me. Anyway, so this is the formula. The quadratic formula is useful because it always works every single time. Even if you get a quadratic function that you can't factor, nothing balances, it doesn't multiply and add right, whatever it is, it will always work. So to prove to you that this formula always works, I'm going to use it and see if we get the same answers when we did the factoring process. I hope you guys are hanging with me, all right? You're doing great. Okay, so we're going to go back to this original quadratic equation here. X squared minus 11x plus 24 equals 0. And I'm going to just rewrite it down here so I don't have to keep looking up and down and moving the screen. Okay, I'm going to rewrite it here. And I'm just going to use this quadratic formula and see if it gives me 3 and 8 like I got when I factored it, okay? Because remember, even if it always works no matter what, okay? So negative b, well, the b term is, this is tricky, negative 11. So if I copy that into the formula, I have to do like this. Negative comes from the negative b, but b itself is a negative number, so I had to put that in parentheses. You with me? All right, plus or minus, now watch this. The square root of b squared, so there goes that negative 11 again. Anytime we got negatives, and I like to put them in parentheses, minus 4ac, so minus 4 from the formula. The a is 1, even though I don't see it. It's a 1x squared. And the C is 24. Woo! All right. And remember, it's all, sorry about the camera work here. Let me do that. All right. All over 2A. So I highly suggest, exactly like I just did for you, I'm a big proponent, put parentheses with your B. And anytime you plug in an A and a C, you just put parentheses. Anywhere you see the variables that you got to substitute in, all right, it'll put you on the straight and narrow. Okay, now first thing I like to do with these is this, I like to clean that up. If you got a negative times a negative, double negatives, you know that's just really going to equal a positive. So I'm going to go ahead and write that as a positive 11 plus or minus the square root. And we're going to just kind of break this sucker down. So I got 11, negative 11 to the power of 2. 11 squared, I believe, is 121. And a negative times a negative. So that works out. And then I'm subtracting whatever this product is. So I got 4 times 1 times 24. Well, 4 times 1 is still 4. So we really got 4 times 24. All right. Well, 4 times 25 is 100. And it's going to be 1. So I'm thinking that's 96. Okay. 96. Now, bringing everything down, 2 times 1 is really 2. And I just simplified that whole messy situation to look a lot cleaner, right? That became 11. That's really 121. And 4 times 24 is 96. So here's where I am, right? So we're almost there, but we've got to keep cooking, all right? You got the square root. You got to figure out what 21 minus 96 is. Well, 21 is about 4 more there. So I'm thinking that's about 25 once I do the subtraction. You can use a calculator on this if you need to. I don't care. All right. And looky here. Just so happens this is a nice pretty one because that is a perfect square. The square root of 25 can be evaluated. So guys, look. You got positive 11 plus or minus. I'm going to go ahead and rewrite that as whatever the square root of 25 is, which is, you're right, 5. All right. Looks kind of funny, doesn't it? You got 11 plus or minus 5 over 2. Well, remember, the plus or minus literally means you do it once where you're adding and you do it once where you're subtracting. So what this says is 11 plus 5, if I need to write it, I will. 11 plus 5 over 2. Well, what's 11 plus 5? That's 16 divided by 2. See that? Is really 8. Circle it. 8 is a solution that we got when we factored it. Now see how much easier it is to factor it when you know you can factor it. That's why if I can factor it, I usually do. But this still works. Just take some time. Okay? And don't forget, this also says 11 minus 5 over 2. So I'm going to do it again. I'm going to do 11, but this time I'm going to subtract the 5 over 2. You see? And 11 minus 5, last time I checked, was 6. And 6 over 2, see that? 6 over 2 is 3. So check it out. 8 and 3 are the solutions. The quadratic formula did work. Okay? It's a bit of a doozy when you first do it. But just like a baby, it looks like, it's easy for us to walk. But it seems difficult when you're a little baby and you're first taking your steps. Okay? But I don't want you guys to be fooled. You will walk. And then you will run. And then you will ski and all the other stuff that you want to do later. Okay, but first you got to start with a few baby steps, okay? So here is a nice breakdown of the quadratic formula. Please, Matthew and Nick especially, but the rest of you guys, look up the quadratic formula song on YouTube, the cartoon one. It is too funny and a little shocking, but also educational, okay? So I hope this was helpful. I'm going to be posting the homework that's due Tuesday on this very subject. And I want you to practice doing some of them via factoring and some of them with this quadratic formula. And we're just going to try it, make some mistakes, learn from it, get better, and we'll learn. All right. God bless you guys. That's it.